Welcome back, ladies and gentlemen. I hope everyone is well prepared for the following session. I am Chen Yan, glad to be your MC in this afternoon session. Now, we are going to invite Dr. Lim Chi-han to give the talk about COVID-19. Dr. Lim Chi-han is a senior researcher at Third World Network. Dr. Lim is a scientifically trained researcher who holds a PhD in infection biology from Hannover Medical School, Germany, and a master's degree in immunology from Imperial College London. Let's give our big welcome to Dr. Lim by sending emoji.
Hi, good afternoon, everyone. It's my pleasure to be here. I'm glad to meet you. Thank you, Ian, for doing the liaison work. I've been in touch only with her, knowing just her before this, and glad to see all of you now. And thank you for the organizer, BIOSS UTM, for having this Edify program. I'm glad that everyone had deep interest in this issue. I guess I'm sure the pandemic will still be around, hanging around with us for another year. So just be prepared. And vaccination, when the opportunity comes, please grab it and get vaccinated as early as possible to protect yourself. Later, I will explain about the science behind the COVID-19 vaccine so that you can gain a better understanding. I'm not sure what biology knowledge level you have, but I would give something very general so that for those without any prior knowledge we could also understand my presentation. I will do my best. So let me share my screen right now and I can begin my presentation. Yeah, if you can see my screen now. Is this okay? Everything all right? Yep. Hi, my name is Jihan from Agora Society, and I'm a co-founder of for Agora Society, and also a co-convener for People's Health Forum. And this talk, I would mainly talk to you about the science behind COVID-19 vaccines. Ian told me I can have a 1 hour or more to talk to you. Although this sounds like a university lecture, I hope I won't bore you with all of these facts. If there's anything you don't understand, you want me to clarify on the spot, you may do so, or you can also, we will have plenty of time for discussion later. So yeah, just probably put your questions in the chat box and then probably I can look at it later, because probably what I will explain later in the later slide could also answering those questions, queries in your mind. So probably it's good that you can see through the whole pictures first. And why this come about, I guess when the first batch of the COVID-19 vaccines arrived in Malaysia, that was February 21st actually, in KLIA. Not until the 24th, our Prime Minister Najib Yassin got the first shot. That's the picture you can see is on the 24th. So that's the first person who received the COVID-19 vaccine in Malaysia. Yeah, so then we know that the program, the PIC program Imunisasi COVID-19 Kebangsaan has been launched somewhere in January, and the MOSTI and MOH work together in this joint committee. Okay, so this some my disclaimer. I declare I don't have the conflict of interest, and I do my best, like I say, to talk to deliver a talk in a more digestible way, so that you can understand the things better. It's purely on my scientific knowledge and judgment, the things I share with you. You might not agree with me, and later probably we can engage with that conversation, because science, you could have if you have something you have insight in that, probably you could also argue in another way. But I am happy to engage with you. Okay, so this topic actually has been delivered before in one of the workshops organized by my societies. That was back in March. I also from Ian, there's probably the instance that the organizer came to know about myself. I was the main speaker for this workshop it also has a duration of 2 hours. I spoke about 1 hour and 15 minutes time. This is the outline for today. I'll generally talk about the trend of pandemic and vaccination. I will give you a picture of the battle of immunity, the virus versus our human host, and tell you about the types of vaccine, the design rationale, and the development status right now. People talk about efficacy a lot. How to interpret a result is it's a big challenge. There are actually many things to understand what does it mean and in what context and in how the clinical trials actually conducted are very important. Then people say, why bother? Because after you got vaccinated, also there are chances that you get infected. So that's actually not very true. It's true that you probably could get infected, but there are three levels of protection I want to convince you about later what the vaccine can confer you. And now we talk about the biggest challenge of vaccine efficacy, that is the emergence of the virus variants. Talk to you about two or three variants that can be found in Malaysia right now. Finally, it's about the program, the PIC program. Yeah. So right now in our country, we are experiencing the fourth wave. But for the global world, it's generally called the third wave or the. The situation got really worse in India, especially. You can see that the cases actually peaked just not too long ago, about 2 weeks ago, globally on 23rd of April. That is quite close to 1 million cases per day on that day itself, and 15,000 deaths on 6 days later. Yeah, so the challenge definitely is not over, and the worst, we hope it will come to an end with more and more people got vaccinated. But the challenge of vaccination is also huge because no one is safe until everyone is safe. So the same goes to vaccination. I will explain to you a bit about that later. And you can see which are the regions contributing to the latest spike in the pandemic daily infection number. Is mainly in Asia, Southeast Asia, including South Asia and India. So the purple is a composition that you can see the spikes mainly coming from Asia, although you can see the spike in certain European countries as well, and South America. So I always want to tell people that the pandemic is a local issue. If you're not controlling well about the border, then it will cross to other regions and will spread badly. But for controlling the pandemic situation is always a local issue, because if the government can control the movement of people, that's why we have the MCO, then you can actually limit the damage, the spread of the disease, because the disease has to transmit through human interaction. That's the key. So people say, why bother about MCO 3.0, and they dismiss the significance. Actually, they could be very wrong. Of course, they cannot bring the cases down to too bigger in 2 weeks. Yeah, but you can see the effect bringing down the numbers soon. Yeah. About the pace, this can give you you can see the timeline from end of the year last year until May 5th. Malaysia is at the this is selected countries only, but it's just probably a bit slightly higher than Thailand and lower than Indonesia. Yeah, so when the vaccine first arrived, when the peak got the first recipient of the vaccine, there are already people, already other countries have probably more than a quarter of people got at least one dose of the vaccine. Yeah, so you need 2 doses to complete. So I can't say the person is fully vaccinated until the 2-dose regime completed. So, but at least you see in Israel way ahead of us. At least half of the, probably close to half of um, the population got their at least 1 shot. But that time, Malaysia just got the first person vaccinated. And zooming into today, the statistics says that it's 2.8, but later I will give you some updates on the figure, because in our program we often say that the population should count from the population I mean 80 years old and above, 18 years old and above. So those minor are not eligible for the vaccination yet. Yeah. So so we want to achieve the 80% herd immunity coverage. That means 18 years old an older population has to be all vaccinated almost, because the population younger than 18 years old actually quite significant, about 30%. We will come to that later. Okay. So people can ask whether it's fair distribution of the resource. This is the figure when in January, 1st of January this year, the time in vaccination program in many countries just started, but a lot of countries started way earlier than us, and there are many countries are without vaccines at the time. Coming to the 24th of February, when we got the first shot, you can see there's some deep blue in the Mediterranean. That is Israel, and then the other deep blue was UAE. They got the Sinopharm vaccines 1 shot, and so a lot of people got covered by that. But by the time you can see especially in Africa, a lot of places still without vaccine access, and some in Asia. And coming to a few days ago, yeah, you can see Malaysia has some color light blue there, but we are still very much left behind. It's not that government don't want to be faster, but you have to understand Malaysia don't have vaccine producers. We relying on vaccine manufacturers from outside, and now our Pharma Niaga and Duo Pharma, these 2 local companies, are doing the fill and finish products for the vaccine. That means they're still relying on for example, Sinovac from China to provide the bulk, so that they can allocate into smaller vials. Duo Pharma will deal with the Sputnik 5 Russian vaccine, but that one is still not yet approved in this country. From this graph, probably I can let you see that where are those vaccines got procured away. You see the color code, the brighter the green, there was more coverage. Malaysia actually got more than 100% coverage. If all the deals they deliver in time, probably we will be okay. We cannot say so for the African countries and in the South America and in Asia, other Asia countries. You see a lot of vaccine supply got locked away by those rich countries. This is also the issues you should care about. Latest progress of our immunization program is that yeah, we have 1.7 million people got vaccinated up until 2 days ago. That's equivalent to about 7% of the 18 years old and above population. Long way to go. We say we want 80% coverage, but there's still a long way to go. Yeah. And you can see that the distribution across the states also not even. Yeah, we know that there are some states which are actually heavily populated. For example, in Selangor, in Kuala Lumpur. But the statistics right now shows that every state at least has some supply and started to distribute a certain amount. I think the biggest challenge must be in the biggest states region, such as Sabah and Sarawak, because of a geographical challenge. Yep. Human pathogen. There are many. Hope you can understand that we are talking about living things and acellular non-living things. Virus is actually a living. Cannot say that it's organism. It can cause a lot of besides parasites, bacteria. We have different ways that our immunity, our body immune system can deal with. Even in the virus family, there are many, 168 families. These are the major ones you can see. Retrovidae is a retrovirus for HIV, and the main character today we talked about is the coronavirus. Coronavirus, if you have a cross section, you can see this is the structure. The main thing is about the envelope, where you can see there are spike protein, S protein. This is the major thing that everyone is talking about. And then nucleocapsid is the one inside that contain the genomic DNA material. Yeah. So there are some vaccines also targeting the nucleocapsid protein, but currently the many vaccine design just targeting on the spike protein. Okay, this is our human cell. You should understand that all our genetic informations stored in the nucleus, especially in the nucleus. It's a kind of library, and when the cell need to give certain kind of instruction, it will pass the information, will transcribe out in terms in the mRNA. So it's like photostate from the book lah, the order. After that, the order has to go out to a factory. We have a ribosome as like if you think the human cell is a factory, a machine, it's a factory of producing proteins, and ribosome is the machine that to produce those parts. And it's all, it is randomly outside the cytoplasm. Those ribosome, it's not that effective if you put in the endoplasmic reticulum. In the rough one, they have all the ribosome attached closely located together, so that they can produce a line of a lot of parts. After that, all the parts will be assembled in the Golgi apparatus and secreted out. Human cell, why they are different? Because of their function, their instruction. For example, the breast cell will produce the breast milk, and in pancreas, we produce the insulin. So they receive different instruction to make certain protein. So this part is very important, because later we talk about the vaccination, how the vaccine designed to work. You can understand how virus and the vaccine actually make use of the human cell to produce certain proteins. And now we talk about the SARS-CoV-2 invasion. Like I told you before, the structure of the virus is in this shape, and the spike actually is like a key to unlock the entry to the human cell. Many our airways, the mucosa layer actually express this receptor called ACE2. So it actually fits nicely, and then it will signal some cell signaling and let the whole virus go in. How the spike actually organized, you can see it's actually a trimeric. So it's 3 units together. You just look at just one unit. You can see there's one area called receptor binding domain. This is the part when 3 together, we have a cavity to fit into the ACE receptor for binding. So that is the key and lock moment. This part, all these parts are important, because this is where the vaccines will target mainly. Yeah. So if you look at from the scale, the correct scale, virus actually tiny compared to the human cell. Human cell can express many receptors on the surface, and probably for one cell can have a multiple virus invade after they unlock the doorknob. So this is just a picture. Once the virus actually got in, one unit is virus, more than two is co-virus. Okay, when they go in, they also want to inject their genetic material into the human cell nucleus so that they can hijack the machineries to make proteins. Once the genetic material injected to the nucleus, they have their own transcriptase, all this protein enzyme to instruct the human cell machineries to transcribe their mRNA and then later make the virus protein. So just like what I said just now, they assemble and then together, and then they bud from the cell, and there you go. You have make more and more virus in this process. So virus actually have certain strategies to pass on their copies. If they are very deadly, that means they probably overwhelm the whole machineries, and then in a short time infect too many cells, cause too much damage. For example, the Ebola, people can die very soon and show great symptoms. Then for health authority, when the virus have very high infectivity and show the severe disease severity, it's easy for the health authority to identify such person and isolate. The problem with the COVID is that the SARS-CoV actually is not so infectious or not so deadly. So actually, it's less deadly than the SARS back in the early 2000, and way less severe than the MERS. So there are many asymptomatic person. You can't know whether the person is infected or not. That's why we got this problem of not knowing who actually passed the virus around. So for the disease containment, disease control is a very difficult job, as you can see in the whole world right now. And there are some mostly symptomless, like common flu, can get somebody like high fever a few days, and some don't even are not aware that they got the common flu. So this is on another spectrum. That common flu you cannot really eradicate, but no one care about that because they're not that deadly. COVID actually it is. If you talk about 3% of death rate, it's also 3%. You could easily have your loved ones or someone you know that affected. Okay, human immune system, and a lot of people also probably share you some secret about, we don't need vaccines. Why bother? We have our immunity. We have nature immunity, they say. So what they say about nature immunity is innate immunity, because those are not learned immunity. We have basic cells such as a natural killer cell, monocyte, phagocytes. They're doing their daily routine of sampling from the environment. If there's any foreign substance, intruders, invaders, they will know. So to them, they don't care whether you're co-vaccine or virus, but they know that these things are not should not be in the human system. It's not recognized as their own parts. So they will flag it up and then pass it on to the next level. So activation of the innate immunity is very important. It's preparing for the next step, which is called adaptive immunity. So innate immunity itself cannot produce antibody, specifically targeting to certain pathogen. It's just doing the normal killing, normal sampling. It's like patrols on police. They're not army, they're police. They probably have a pistol, those basic things to restrain the situation. But you're talking about warfare, then you need army. Police cannot do that. So it's only for the local reactions. So if you have any even after vaccination, you might feel yourself a bit feverish and have some kind of pain, swelling. It's normal because it's a local reaction. This can get very fast. They can feel it very fast within a day, a few hours, because the immunity actually is the innate immunity is doing the work of sampling and pass on information and call more brother sister cells, the innate cells to come to surround the virus, the intruders. So this actually reflects the activation of innate immunity. These are important because after they got hold of the virus, they chop it up and then they will pass it to T cells and B cells. They move to the lymph nodes first. That's where you can find all these adaptive immune cells. So one is called B cell, one is called T cell. I'll tell you about the function briefly. So adaptive immunity is to develop antibody-producing B cells and then memory B cells. Those memory cells are very valuable for the adaptive immune system, which cannot be replaced by innate immunity because we want a fast reaction to specific pathogen. And secondly, it's very important because a lot of people talk about antibody, but they forget the T cells is the main orchestra of all these responses. So development of a T cell response would be very important. So how our human immune system can see the virus? They actually don't have eyes, yeah? So and they cannot see really big thing. So our cells, after especially those macrophage and monocytes, all this, after they engulf the invaders, we have other enzymes to actually digest those proteins from those foreign proteins into smaller parts. We call this splicing. After we splice into certain length for presenting to the T cell and presenting to T cells. These are called antigen presenting cells. Those innate immunity cells just now I talked about, they are all antigen presenting cells. So they chop into 12 to 15 amino acid length, which is a very small fragment, and presenting to T cell. They restrict it on a complex called HLA or MSC2, this one, and the other cell can also have a smaller fragment on the HLA1. So it's different kind of complex to hold the small foreign protein. Okay, but we have to understand for even for just the S protein, just a monomer. I talked about monomer. It has 1,273 amino acids. So what you can see from the cells, even though you have many all this complex HLA complex, it only can chop into this small length. So it's like asking a lot of blind men to recognize an elephant, but it's still working because even though you're blind, you cannot see the whole picture. When you touch the elephant, you know that it's not human, it's elephant. Some cell will recognize, oh, this virus looks like the elephant, the tusk. Some look like the tail, but they will tell the T cell, you see, this is a foreign, it's not our cell. Do something about it. So this is a situation when the cell how to transmit the information to immune cells to take action. This is how they recognize. But you have to understand the virus is more than just a spike protein. We have other proteins I told you before. So the T cells actually recognize very small linear peptides presented by this APC. We'll have so they say that it's actually okay if they have mutation because they have mutation probably on a certain length only. So the other part where they chop, they splice, still can be organized. So vaccine design not supposed to be affected so much by the mutation of the new variants, but we can argue about that later. Yeah. So the CD4 T cells is to produce cytokines to help build the antibody response, and CD8 T cells itself can kill the infected cells and contribute to termination of infection because they also secrete the interferon gamma to call a lot of cells together and do the killing. So this is how it looks like for vaccine or virus when it injects to the muscle. For all the current vaccines in the portfolio, Malaysia portfolio right now, they are all injection. So they will inject to your muscle, not your bloodstream. Yeah, and will get picked up by those antigen presenting cells I talked to you about. And they put the peptide on the MSC class 2 or class 1, and presenting to the CD4 and CD8 T cells. And then once they receive this, they activate this CD4 T cells, then this T cell can also activate the B cells. So through the T cell help, they notify that there's this thing invading. So start making your antibody to deal with it. So B cells actually needs the CD4 T cell to be activated. You know what virus actually attacking CD4 cells is actually the HIV virus. And why these people develop AIDS is because the CD4 T cells got all killed by the HIV virus, so their immunity is all gone. So you can understand how important is this CD4 T cells and B cells connection, yeah. And once they got activated, they need time to mature. They can proliferate into plasma cells. That means they are specialized in secreting a lot of antibody, and they keep some clones into B cell, a memory B cell. So this memory B cell actually is a shortcut later for kickstart certain response. So you don't have to go through the whole process again. You know, some of this plasma cell will store in the bone marrow and keep it for a longer time for memory. So there are some vaccine you receive from child. Probably you don't need to receive the booster every now and then. There are some disease you can still have detectable immune response or level to deal with. That will be fine. But we are not sure about the SARS-CoV-2, the COVID-19 right now. Okay, this is how the antibody looks like. It's like a dancing man with you see the darker region, color regions actually the light chain, which has a specific recognition to certain peptide or foreign substance. The most common one is the IgG, which has the highest specificity. And what antibody do is this four function. First, they will neutralize the virus. So they block the virus, they coat it all around so that they can't get in. Then our human system can just clear it away. So they can't infect us because we neutralize them. Okay, so that's one function of antibody. The other one is co-opsonization, means that the antibody are coating the virus, and then get recognized by our cell. For example, our innate cell, macrophage. Then they will eat it up, and then they do the phagocytosis, means really killing the virus already. The virus cannot do anything once it's coated by our antibody. Then they also can signal the complement to do the killing. So because like what I say, antigen dancing cell will also upload the small peptide on the surface, letting other cells to recognize. Once the antibody also recognize that this cell is actually infected, so they can activate this complement system to kill the cell. And there are also other direct killing methods. Also, the same thing, the antibody recognize the infected cells, and then directly the NK cells or other specific cells can recognize and kill the cells. So in this way, the virus will be gone. So when talk about antibody responses, there are three things you have to bear in mind. One is about the binding antibodies. The quantity does matter. Imagine you want to stop a giant organism such as elephant. If you have produced so low level of antibody, you have to ask like a 6-man blind man to stop an elephant. It's not enough. You probably need 20 strong men to do it. So the more quantity you have for the specific binding antibodies, it will work better. But if you look at the quantity, it doesn't tell you whether it's actually protective or not. Then the next one is a qualitative judgment, is to ask whether this antibody is neutralized or not. That means how good is the binding? If they bind at the wrong area, if you bind at the elephant tail, it probably can't stop the elephant getting into a room. If you, yeah, so the binding area also very important. And thirdly, about the functionality. So even you bind, how tight is the binding, and so there are also other kind of function, so will be very important to determine how good is the antibody functioning. And probably people will ask why certain vaccines will require just one dose and another will need a second dose. You have to understand, after the virus exposure or the vaccine antigen exposure, the first dose will give you the primary immune response. So actually, it will activate your cells and start producing an antibody um, up to a certain threshold level. Usually, probably will give you some kind of protective antibody level at the 14 days after the first exposure. But our immune system and our body also will have to produce other kind of antibodies. So after the threat of the virus or those foreign peptides or antigens are gone, then the titer actually will go down. So it won't be protective enough. If you see from the picture A, this is imaginary line. You need this level to say that you have enough to stop the virus. So if you tail off until below the threshold level, you are not good enough to have the first good response to stop the virus. So that's why you need another dose at a certain timeline later, and make sure now you have a even higher antibody titer, and let the cells mature to develop more specific and stronger binding, then the protective effect is much better. Yeah, so there are other issues that why you should not wait too long, because there are some virus can make you sick very fast. So even you have the second dose, you receive a second dose, it will take also a week to realize the potential of protection with the best protective effect. So if you don't, after the first dose, you just dilly-dally wait a long time, and then you actually got infected by the real virus, then the response probably is not quite quick enough to save you or to make you not so sick. That's why there's always a gap that you should take the second dose, so that ensure your level will tail off above the certain protective antibody level line. Of course, if you have a one vaccine design which is so good that in one shot you already can achieve the scenario C, then it's the best. Then you probably don't have to go for a booster, because it will stay above the level. So why need the booster dose? I talked to you about it already. Just look at the right figure. Actually, it produce you the shortcut. Imagine just now I talked to you about the process of activating the innate immunity and adaptive immunity will take a long time. If you have memory cells, actually give you a shortcut, direct shortcut in this arrow directly to instruct the plasma cells to start producing the antigen-specific antibodies in a large quantity. You can save all the antigen presenting process and activation, this and that. So go directly into producing the antibody. So that's why we need to have ensure we have enough memory cells. Those things can be found only in the adaptive immunity, not the innate immunity. So that, I think you can explain to senior citizens when they talk to you about the nature immunity thing. Yeah, about vaccination, it's not new, because we received a lot of vaccines when we were a child, and our vaccination coverage is actually quite good in many major vaccine preventable diseases, higher than the global average. And don't say that vaccination does not work. I think the prevalent scientific knowledge for those vaccine preventable diseases is a resulting success. This is the data from United Kingdom. Once you have the introduction of the good vaccine, you just bring the incidence down to a very low level. Of course, we need the herd immunity to protect ourselves later on. But if the program, the national program runs very well, most of the people got the vaccination since young, then probably we are all protected. We know that there are some challenges, like 2 years ago, the polio outbreak started in Sabah, and now and then you can see there are some cases of measles and diphtheria, and we know that there are many active anti-vaxxers around in the country, and a lot more not willing to get vaccinated due to certain reasons, for example, religious reasons, because they fear that it's not halal. Then this actually contributed to some outbreak, for example, diphtheria. I know that I heard, I think it's 2 years ago or so, that there were case in, I think it's in Kedah, that somebody died from diphtheria, which is a very sad case because diphtheria is a totally vaccine preventable diseases, and the kid did not get vaccinated. Yeah. And now I'll talk to you about the kind of vaccines. We have plenty of different types. I'll talk to you about 5 types. This type, live attenuated vaccines, is very famous because a lot of our vaccines actually we use this. It has been shown to eradicate smallpox. This is also the first design of the vaccine from the cowpox. Yeah, story. Yeah, if you have heard about it before. So it's the most traditional technology, very effective in introducing a strong and persistent immune memory. But the problem is it carries some major biosafety risks because it's a live virus. And if someone's immunity is not good, for example, for those immunocompromised individuals, they can get severely sick, even though this is already a very weakened virus. Currently, very few manufacturers for COVID-19 actually producing using this method. The second method is inactivated vaccine. Most famous one is the Sinovac and then the Sinopharm. It's also a very traditional technology. It's much safer and more stable than other types of, for example, more stable than the live attenuated vaccine for sure. It actually gives you an advantage because you kill the virus, but you still have the whole virus for the immune system to recognize. It's not just spike protein; it's everything. Because once our cells engulf the whole thing, also will chop up every part and pieces. So you actually have other kind of protective effect, targeting different parts. So it's like a insurance policy. The con is that because this is a dead virus, it's not exciting. They don't do anything to you. So you need some adjuvants to excite your body, telling people, see, this is a danger thing, danger signal. So probably they demand a higher volume or amount of inactivated component to compensate the general weaker induced response. And it has probably the problems of shorter memory because it's not working that well because of the nature of this vaccine. But I guess if you have more booster, probably it would definitely need booster for this. It's not a problem, but I guess the side effect will be the less from I would expect from this kind of vaccine. Then there's one design called the vaccines is based on the protein subunit. So you actually insert this protein subunit into the body. So it's not the virus anymore. It's just a protein injection to your body. You can easily produce. You can ask the cell line to produce. Even you ask the plant to produce. Nowadays, people targeting on just producing the spike protein. Because this is also not a pathogen, it's just a protein. We eat protein every day, so it also needs some kind of adjuvants to excite, to activate the whole immune system. And currently, we have this Novavax, which is, I don't think it will be used in our country. And I also know that many manufacturers in Taiwan also going for this protein subunit type of a vaccine. Then this is a famous one from only currently have two in the world portfolio. It's a very new technology called mRNA-based vaccines. It actually what it does is that it will have a mRNA code encapsulated in liposome. Lipid means a fat. To inject into your body, so that you hope that the cell, all your immune cells can pick up this this mRNA, and this mRNA will go to your mucosome to produce the spike protein. Now they have all this targeting just on spike protein. Yeah? So the mRNA is an instruction to produce the spike protein. So in the way, after you producing the foreign proteins, it will also get carried in presented to your immune cells. This technology was probably 6 years ago. They figured out how to make it work better, because when I started studying about immunology and microbiology at the time, they try to induce it outside the body. Means they extract dendritic cells from your body, and they try to mix it outside and then put it back to your body. Those are the old technology, which is not practical at all. So they have issues how to make the mRNA more stable, because if mRNA just lying around in the bloodstream or in the muscle tissue without the liposome to protect, it will degrade very fast and won't get into your cell. So and also another concern is that if this mRNA does not purify well, then we have double-stranded RNA. This actually is quite toxic to your body. So the double-stranded mRNA is an issue. So they have to do very high purification to ensure only one copy go into the liposome. So this is a quite delicate technology. Only two manufacturers right now. It's untested. We don't know, because there's no other using this technology. Never registered before, and it needs an extremely low temperature. Although the Pfizer say, it actually can be also alternatively used in -20 Celsius for shorter storage period. They say it can be done, but for right now in Malaysia, we have to ensure it's always lower than -60. So it's a deep freezer. Those are very, very expensive freezer. Probably it's as expensive as one of your MyD car, for one deep freezer. So the cold chain and storage is very requirement is the government have to really plan and arrange. I think it's logistically very difficult compared to the AstraZeneca vaccine, where they can allow you to just pre-order and you book your slot. I think for the Pfizer vaccine, it's very difficult to do so because of the temperature requirement. And there's also some unknown risk about this mRNA. It is entering the bloodstream, going to the wrong area, for example, your nerve cells or your heart cells, or don't know. It can cause some autoimmune damages because if the wrong cell express the foreign protein, the immune cells were mistaken for any foreign invasion, foreign substance invasion. For example, don't know, other kind of pathogen infected cells. So they will also kill your cells. But you know that there are some cells are not replaceable. For example, nerve cells. What is damaged is gone. You can't replace it. So for this, still people are studying on it. So far, there's no big concern, but we don't know about long term. Yeah, so there's some reservation about this technology because it's a very new technology. now we talk about the viral vector vaccines. The Sputnik and the AstraZeneca are part of them in our vaccine portfolio. So what it does is that it also will carry the SARS-CoV spike protein mRNA instruction, okay, the coding instruction. But instead of the real virus itself, it asks another virus called the adenovirus to carry the sequence to code for the full-length spike protein. Well, this is relatively new, but it's not totally undone because Ebola virus white vaccine also used this design before, but it's within this decade and not more than 2 decades ago. Okay, so it's still quite new. So it will exploit other virus ability to infect to deliver the mRNA. So some are able to replicate to further stimulate the immune response. So you actually get more response from using this method. That means probably will experience a much worse side effect. Probably it's not bad because this virus is not really going to cause you a lot of problem, but it's still a kind of infection. They have to infect you to deliver the mRNA so that the whole thing can work. I heard from many friends who got the vaccine, they're actually quite a bit sick. You probably have to expect the next day, for at least 1 day, you got enough rest, high fever, all this is possible, yeah, for this. The cons is that the pre-existing immunity against the virus vector might affect the vaccine efficacy. Why? Because currently this vaccine design is still new. If you have used this vaccine, this kind of vaccine before in the past for other kind of diseases, then you're compromised because if your body react to adenovirus instead of the S protein, then before they can infect yourself, they already got clear away. So the vaccine won't be for any use. That's why that's why the Russian have some kind of clever design. They have two doses, and they use 2 different kind of adenovirus so that your body won't really clear the second virus because of the first exposure. I don't know whether you understand what I mean. Yeah. And then you can see the AstraZeneca, they don't use the human adenovirus. They actually use the chimpanzee adenovirus because no one used the chimpanzee before. Yeah. So the chances of the pre-existing immunity against the viral vector will not be there. Okay. This is the world picture right now. We have 6 authorized vaccines and 8 approved in the world, especially in US. 27 right now in the 3rd phase. These are the leading developers. 5 of them are already in our portfolio in Malaysia. And the 4 types I talked to you about, you can see it here also, is used widely. You can see for the RNA vaccine, the mRNA one, why is it like this, the distribution compared to others? Like I told you, the logistic is very demanding. For developing countries, for example, lower income, they can't actually use this because they don't have a cold chain. They can't invest in the deep freezer. That's why in developing countries, you don't see people using this one. Although it sounds cool, maybe it's quite effective from the efficacy test result, the trial result, but it's limited use. Also very expensive compared to other type. Then you see the inactive virus vaccine, we have more candidates because this is traditionally produced vaccine design. A lot of manufacturers already have the know-how to make this. And why also you can see the adenovirus vector kind of vaccine also widely used because AstraZeneca one is much cheaper compared to other vaccines manufacturers. Sorry, yeah. It costs actually twice cheaper due to public investment by the Oxford universities. So the company AstraZeneca actually don't need to make a lot of investment, so they can market down the price, and the requirement of the storage actually is just normal vaccine temperature. So it's cheap and logistically easy. So a lot of countries, including developing countries, want this virus. And the protein subunit one, we're still studying and not sure, it's not really picking up yet. And these are the 5 in our portfolio right now. Currently, we have approved these first 3, Pfizer, AstraZeneca, and Sinovac. The Sputnik 5 will be locally fill and finished by Dual Pharma, our local pharmaceutical company, but it's not approved yet. These 2 have not approved yet. All need 2 doses except the CanSino. I don't know when it will come. Why we can do it in a very short time is because if it's for the traditional vaccine development, you will need quite a long time to come to the 3rd phase and then got the license, and then only you start producing. But because this pandemic is so serious, we want to get things very fast. After the success of the first 2 phase, they already start producing and anticipating for the license. So everything overlap together. Excuse me. And a lot of people also actually don't know what the clinical trials means. Phase 1, phase 2, phase 3. And actually, it has different purposes. The phase 1, before phase 1 is they can do the lab study. They use cell lines, they use animal models to do some study whether it's working or not. Some scientific check. The first one is the first phase. They would just need a couple of volunteers to do some kind of study. So it's a real human clinical trials. The objective is to understand which dose is good for this vaccine, and whether it will cause immediate adverse events or reaction, all this. Then secondly, after you got the data and you can adjust, then you will enroll more patients. The phase 2 is like a mini phase 3. Mainly to see the immunogenicity. Then you have to measure a lot of antibody titer, how good is the binding, and then you should enroll patients with different characteristics. It's like a mini third phase. Third phase is large scale. You need to have 2 groups. At least one is placebo, one is experimental, the vaccinated one, to compare the result. Usually for one group, you need to have at least 10,000. So 2 groups means you have to enroll more than 20,000 for one phase 3 study. Then after you got everything done, the result is nice and everything shows that it is safe and it is working, then you probably got the approval. After you got the approval, also the authority will keep monitoring on to evaluate your vaccine, so that if there is any adverse event, anyone have to immediately report to the authority so that they know what's happening and probably can adjust. And for the third phase, usually they exclude a lot of people also. For example, pregnant women or HIV patients, adolescents or children are not in the phase 3. And after this, then probably the approval for the adults, after they got the approval, then they can start doing the clinical trials on children and on other demographic groups. So this US and WHO requirement for the WHO actually has the efficacy of 50% they can take. The efficacy, it means a lot of things. Later, I will probably explain more about it. Currently, just to let you know, there's certain requirements they have to go through. And for our side, the MPRA is the authority that give the approval. It's not just for vaccine, and it's for every drug registered in this country. Excuse me. Is very, very stringent. You can talk to any industry people, you can understand. It's probably a pain in the ass to really go through this registration. Just to look at the application, just on appendixes itself, you can see 34 appendixes for you to go through to tick all the boxes and meet all the requirements. It's not easy. Even the labeling, the language used, and the booklet, and they have to go to your plant for inspection. If your plant is outside in Russia, they also have to go there and inspect. So it's not, so you have to be really confident in their working. It's good that we don't need to always follow the US and Singapore. If they got a virus, they got approval, so what? We have to do our parts as well. It's not that we just follow other people. We have our own standard. How to do the clinical trials? Usually they follow the randomized control trials. I guess I think for the interest of time, I won't tell you too much about this. Just like I say, there's a vaccinated group, there's a Facebook group. There are people got excluded for certain reason, and they are follow up. Sometimes people don't show up, and sometimes you have to disqualify some people. So that's why this affect the efficacy result a lot. Just from the first from the first one about the eligibility, already you set certain criteria. Yeah. Double blind means doctor and the patients won't know whether they got the placebo or the vaccine. Yeah. Efficacy. The third phase I told you about, the data gap is for children, pregnant and breastfeeding women, and many categories of immunocompromised person. And so those enrolled in the studies, mostly the okay, healthy 18 years old and above people, and they make sure they also stratify the age, the demographic by age, means older people, different races, all this. The efficacy, well, there's some numbers here. There's some variation. For example, look at the Johnson & Johnson. It's 72% in US compared to 57%. Some use different dosages, show different result, and I will tell you more about the South Africa situation. First, how to interpret, okay? For the Johnson & Johnson in US, this is the result. So one group is a placebo, means they don't have they receive the vaccine just without the vaccine. It's just sugar water. Another group is vaccinated group. After certain period, they will collect, there's an endpoint. Once probably the placebo group hit, let's say 200 infected person, then they will ask what is the number on the other side. Okay, so you have to standardize. For example, this on this place in this instance is the number per 5,000. So these both sides are now equal. So it's the result is a 63 per 5,000 on this placebo group compared to 18. So if the vaccine is not working, means you should expect the vaccinated group to have 63 or so. Yeah. So also it doesn't mean that placebo group will have all the volunteers got infected. That depends on how bad is the pandemic situation in their country, in their place itself. So the 72% means that is 72% less risk compared to the placebo group. This give you the vaccine efficacy. But for and then this is a worldwide one. Once you campur South Africa, Indonesia, another country, because the pandemic situation is different in the setting also different, and probably the groups that you enroll could be also different. That means now you have see a lower number. Does it mean that the vaccine work less efficiently? So that's the question. But one thing for sure is that if you talk about severe cases, or for example, hospitalization and death, just look at the number. The vaccinated group, very rarely you can find people very sick after infected by the real virus. So the numbers usually close to 100%. For this Johnson & Johnson is 85%. So what actually makes the difference between the efficacy? And first is the study population. If you enroll more healthy person from younger age, I would say the chances that someone develop a worse disease or probably die from disease is lower. It's due to chances, yeah. So it depends on who actually you put into the study. Virus characteristic means if the virus strain in your country right now mutated, the vaccine is originally designed to have a reaction to the original strain, then it's not matching, and probably the efficacy will go lower because it's not working ideally. Force of infection means the pandemic situation or the risk situation. I remember the Sinovac clinical trials in Brazil, actually is in the very high risk setting, means they use medical frontliners as the subject for the clinical trial. That's why they got the close to 50%, and a lot of people say, oh, we don't take Sinovac because it's not that effective, but because the group they've chosen is the highest risk one. So you will expect a lot of frontliners will get infected, but they are not going to get very severe diseases. And so the definition of time point endpoint also very important. Yeah. Sorry. We know that the vaccine needs to take time to get a mature response. It takes time. For example, after the second dose, to reach an ideal level of protection, probably you need at least 2 weeks after the second dose. So if the endpoint you put it too early, that means there are people probably can get sick and got recorded for bad efficacy, because you see your vaccinated group also got people infected. So if you put you start counting from a longer period, that means it will show better result. So it's how you play the game. And the timing of the vaccine efficacy. So if you have a longer follow-up, you pick up more cases. And performance bias, if the country using certain kind of measures of preventive, for example, MCO 3.0, or they use certain measures to keep yourself from getting infected, then that will also affect the efficacy result. So the numbers, just not the number, you have to ask how they do the clinical trials. So I want you to look at the efficacy in terms of the asymptomatic infection. That means you wouldn't know you got infected unless you do the PCR test to show that molecularly, diagnostically, you are infected. Symptomatic means if you are coughing, you have shown the symptom, that means you got a bit more of the disease, and then moderate, severe, and then death. So this is a level, yeah. So for the severe disease, vaccines across the board protect you convincingly. After the first dose, the protective effect actually started, but usually you need the second dose for the maximum effect. So this is usually the clinical trials will show you the placebo curve and the vaccine curve over time. On the left is the Pfizer and on the right is the Moderna. Actually, it looks the same. When you look at the smaller insert of the left graph, shows the very beginning of the first dose. If you look at the yellow, the red and the blue line, for the first 10 days, actually, there's no difference. So don't get so happy after you got the first dose of the vaccine. Actually, it won't give you any protection until at least 10 days later. It's normal. Just now I told you about how our system got activated, the immunity, how you need to grow, the B cell to the activator mature, producing antibody. It will take time. So don't get so happy once you got the first dose. To stay vigilant. The best effect protective effect only comes the second dose. And it's not true that there are no evidence for the Sputnik and China vaccines that to show that their vaccine is actually working and safe. Some will actually argue that there's a transparency issues, but rest assured that all this information they have to provide to the national authority for approval, so they have to come clean and give everything. But in public, yeah, you can say that there are less materials or the peer review materials that you can refer to, but there are still some. For example, the Sinovac is quite good response if you look at the immune response to the elderly. Give you you can see the response they have two doses type. Yeah, this is for clinical 2. All shows the zero conversion rate, means all you can find the antigen specific antibody. They're all producing, even they are all no problem. This is on the Pfizer. The red bar actually is the those recovered patients from the infection. You compare the antibody level. Yeah, the top part is the S protein binding titer, and then the second one is talking about neutralization. The left part is 18 to 55 years old, and then the right part, the right panels are for the senior citizen. Actually, you see not much difference. That means it's working well also for the senior citizen who after the second dose, the first dose and second dose, 7 days and 14 days after that, you see your antibody titer is at the maximum. Actually, could be even higher than naturally infected patients. There are some follow-up studies after 6 months that your antibody still there, not telling off that much after the second dose. That is for Moderna, regardless of the age. Although for neutralization, the senior citizen have the telling off effect a bit more severe, but they are still way above the threshold line. So after 6 months, still good so far. Israel already have some, they are first to get the nationwide vaccination. There are plenty of results to show that it's safe, it's actually working. So the study actually shows the effect after the first dose, how many days after the first dose, and then the 7 days after the second dose. The efficacy number is high for documented infection, symptomatic, even death is it's not recorded. There's no people die because of after you vaccinated and infection. Later on, they also provide the breakdown for different demographics, and it's all good. This shows that the Pfizer should be safe to use and it's effective. And people would ask about side effects, and these are the common side effects on the left: fever, headache, nausea, chills, fatigue. For the first shot, it's less severe, and second shot is more. That's for Moderna. I'm not sure this is from the clinical 2 trials, second trials. People actually experience stronger side effect after second dose. But these are the normal side effects. It's not really severe. People more concerned about the AstraZeneca due to the blood clot scare, and you see a lot of headlines talking about that. And scientists are actually still trying to investigate why is it so. But to me, the risk is still very low because you talk about blood clots. if you really got infected by the SARS-CoV, the risk is uncomparable. That even though if you just there are other behavior or action that you do on yourself actually have even carry even higher risk of blood clot compared to getting the vaccine. This picture is shown by our DG Xiang, and yeah. So also this is the graph provided by the KKM. It shows that why you should not worry about the blood clot. Although right now the scientists still don't know why, but we cannot. There's a link. We find that there's a small tendency of increase the risk. But like I say, there are other things also can increase your blood clot risk. And you know, this blood clot, if you can see that you have certain symptoms, you should immediately inform the authority so that actually this blood clot can be treated. It's not the worst if you've got the blood clot or you start to see some symptoms. If you notify early, you will get safe. So it's treatable side effect, yeah. MOH already assure you they will treat you. So who can vaccinate, who cannot? Singapore made it very clear. Actually, virtually everyone can accept that if you have a history of anaphylaxis, means a severe, strong allergic reaction immediately after the vaccination. If you have this kind of history, you have to notify the authority. If you have a severe weakened immune system, for example, you are AIDS patient, or you just undergone chemotherapy, it's not good that you go for vaccination at that time point, because your immune system is not well built to actually develop into give you the protection. Or if you have a very low platelet count, this is to prevent you have kind of blood clot things. Or low platelet means you are easily bleeding. It's also not good. They don't want to have this thing happen. So, for example, if you got dengue, during dengue time, you got a very low platelet count, you shouldn't go for vaccination at that time. That doesn't mean that you should be disqualified. Probably just temporarily, once you got your platelet count back to normal, once your immune system after your chemotherapy back to normal, you consult with your doctor, you can also take your vaccination. So other kind of risks like diabetes, hypertension, asthma, all this, no problem, just go for vaccination. 3 types of protection. One is to prevent you from getting infection. Secondly is to reduce the severity. Third level is to prevent from serious diseases or death. And I mean, probably that person after vaccinated can also get infected and maybe can pass on to the next person. But you are still protected yourself. Okay, but can reduce the transmission rate greatly after the vaccination. So 3 level. The best scenario is that of course no vaccine will infect you, but there are variation of protection, because we are all different human beings. We have different level of immune system. We cannot just compare like that. So there are bound to have people showing lesser protective effect. So like I told you just now, why this happened, because I mean, people will have different kind of a profile. Maybe you didn't produce enough antibody level, or probably your development, the maturation of the antibody is not that specific, binding is not that strong. A lot of issues, a lot of different reasons why we are different. But to avoid severe disease is shown the result, after the clinical trials phase is very strong, that it will protect you from death, from severe diseases. So you can see there's no person actually need to get hospitalized because of the real infection. And first dose probably already good to reduce the asymptomatic transmission already. This is in the UK, Cambridge University healthcare frontliners setting. So they are high risk. So they compare the unvaccinated and those are vaccinated. They find that they swap every now and then. They find that actually if you are already vaccinated, it's less chances for you to really pass on your infection to the next person. So that's the result shows you actually first dose already would be good. This means Pfizer vaccine they're using. Yeah. Secondly, even if you have already infected and now recovered, there's still chances that you've got reinfection. Is possible, but the result also shows that there's no symptom. They also use the healthcare worker here as an example. The seronegative versus seropositive. Seropositive means those group already infected before. You can see there are also people like 2 out of this 1,265 show up with a positive test. That means they got infected, but they are no issue. There are no symptom. If you look at the zero there on the right panel. Next concept is the herd immunity. You need people to have the whole population to get the vaccine coverage above a threshold level so that you can protect those who cannot get vaccinated. For example, the blue person on the right, once a lot of people got vaccinated in orange, you actually protect those persons that cannot get vaccinated. But if the rate is low, that means it's very likely that they can pass on through all the cracks and loophole because the protection, the coverage is low, and then those in blue will be in danger. So that's why people talk about herd immunity, although it's a very difficult concept because the protection is not complete. I mean, to really prevent people from infection. And there are a lot of people actually hesitate to take the vaccine, especially among the adult population and the elderly. So this is a huge challenge. Good thing is that the efficacy right now is shown to be very high for the Pfizer. Probably we need lower number of people got vaccinated can sort of give you the herd immunity protection. The biggest challenge probably right now you heard about the VOI, VOC, VOC. VOC, for example, it shows that we have these variants of concern that can infect you easier and cause more severe diseases. And there are some evidence of this virus escaping the vaccination effect. So the variant of interest just means there are certain markers that show they have this tendency. This high consequences means there's a totally breakdown. I mean, those vaccination you take can't deal with the new variant anymore, and probably we need to find a new resolution. Probably have to use the updated vaccine to deal with this variant of high consequences. Currently, there's no variant of high consequences happening right now, but we have quite a few 5 variants of concern actually listed by the CDC US. In Malaysia, 2 already arrived on our shore. One of the SARS-CoV-2 variants already here is the UK strain. I mean, if you remember, this is not the VOC. It's last year. The Wuhan strain is the orange one, and got replaced by the UK strain. It's not VOC, but by the end of May, so in our country, it's all this UK strain already they taking over because probably they prove themselves is a more powerful, more effective pathogen. Variant concern, these 3 are the biggest right now. The UK variant, the B117, the South African variant, and then the Brazilian variant. In Malaysia, we have the South Africa one. We have 48 cases already in Malaysia, but all I think is under control because government have to do the surveillance now and then. They actually through the genomic surveillance they find out there are some carry this South African variant, and UK variant we have 8 cases, and also we have 1 BOI, the Indian variant, just one imported from India. So the threats are actually knocking on our door. Just to give you an overview about how dangerous if we let things uncontrolled, because the South African variant, they got dominate in just 2 months. If you look at the variant's composition for the daily infected cases, from the end of the beginning of October until the middle of November, in just 2 months, the yellow bar just dominate quickly. This shows that this variant is really infectious. Why? There are some mutations in the receptor binding region and then in the spike protein. So like I say, this mutation sometimes there are some random mutation actually can be weaken the virus. So we don't see that because it won't give them any advantages, and probably they can wash out. If there are some emerge become successful because they are binding COVID, their mutation give them the advantage of binding more strongly and can evade the immune recognition. So the main if you look at the orange side means all the mutated point on the receptor binding domains and then the N-terminal. So if you can see, this is how your antibody bind to the virus. If this area in the circle got mutated, the binding won't be that good. So that there's then when you talk about neutralization effect, you can't hold it that tightly. That means you are less effective. Already shown that the neutralization effect can go can drop significantly once you use the titer from the recovered patients, or the vaccine induced one against these variants. About half but knocked out is below the level, so it's not good. And this also for Moderna and Pfizer, that's the case. So this B1614G is the current development also in our country. That's not a problem compared to the UK, the original Wuhan strain. But for the South Africa ones, we can see some concern of reduced efficacy. Yeah. So that shows up also in the vaccine trials in South Africa. Because whenever they do in South Africa, you just see low number. It's because the current design is originally targeting at the Wuhan strain. It's not the South Africa strain. So there are some concern, and all the manufacturers actually stopped the clinical trials in South Africa after these strains become dominant. But nevertheless, protection they compare to you is not only entirely on antibody. All this the effect just now the show is on antibody, but on the cellular immunity actually is still intact. Okay, I think I will finish very quickly with all this national program because you know already. Now we are in the phase 2. There's a lot of information if you just look at the program itself. You go to the website, that's where you can get all the latest updates, register yourself. You can also, beside your MySejahtera, you can also do so through this website and check your status. Can help other people to register as well. You know, the AstraZeneca registration that time, everyone go to this website and do it. And if you want to know where you can get your vaccine, there are 382 locations. There's a list there, then you know where you should expect to get your vaccine. So all in all, sorry I took a bit long time. It's really 1.5 hours. No matter what vaccine comes to you, you just go get it. I told you already, NPRA standards is very high and stringent. Any approved vaccine should be safe for most people. We cannot rule out any side effect, but the 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 risk won't outweigh the possible harm brought by the COVID-19, the real virus, and the risk of side effect can be managed. Okay, can be managed and treatable. So I hope people after my long presentation or lecture, you can discuss the vaccine issues based on the credible information, because there's simply too many misinformation out there. So do not simply share without thinking. Now you're more aware after I told you about all these scientific facts. So I hope you will clear the cloud and confusion by others, and you won't join the group that keep on misleading other people. So I thank you for that. Sorry for the long lecture.
Thank you, Dr. Lim. Now we open the Q&A session. Please feel free to ask anything related to the topic, and we welcome any thoughts and comments as well. So now I received some questions from the audience. The first question is, what kind of side effects will the people who have been vaccinated getting?
Yeah. Maybe I just refer back to my slide. The answer is here. The common side effect, which is not considered as a strong adverse event, if you have you experience fatigue, fever, chills, headache, nausea, only local effect. I'm sure because you got injection on your muscle, you will feel swelling, pain. It's normal. Probably your entire arm for 2 days is you can't really use it because it's so stiff and not comfortable. Actually, this is quite common. I think last year I was accident I experienced. I have to take the anti-tetanus vaccination. Also for a few days, my hands also very swollen. So this is not a big thing because I think you can monitor. If you got very high fever, then and you got a shortness of breath, there's something more severe than that. You have to seriously go to inform the authority. For example, you have a blur vision, you know, beside all this, the symptom. That's why I talked to you about this. Yeah, these people, drowsiness, seizure. Seizure is a very bad thing. So, shortness of breath or chest pain, definitely a red flag. If you got this, go see a doctor straight away, because it's very serious. If you got headache, okay, you can use painkillers. Anything, or for fever also, it's okay. If it doesn't get better for a few days, then you have to also inform. Other than that, if you worry about the blood clot, also you have to look if you have seen any suspicious inflammation, some inflamed area with a tiny blood spots, also a red flag. You better tell the authority that you have these symptoms, because so that you can have time to deal with it. Other than that, most people will be just on this side lah. I think you should give yourself a day of rest, because I think fever and headache, all these fatigue, all these are quite common. Okay.
So thank you, Dr. Lim. The next question from the audience is, I remember doctor mentioned the storage to keep the vaccines are too expensive, like one mighty car. Then why must some vaccines are needed to be kept in such a cold temperature?
Yeah, that's for the mRNA vaccine. Yeah. Why? Because mRNA is just a very unstable molecule, and like I told you, the technology right now is encapsulated in the liposome. For the liposome to not deform, to keep the shape, they need to be put in very cold temperature so that it can keep intact the kind of a structure. And there's also a procedure for you to slowly defrost the vaccine. You cannot simply just take it to the room temperature. That will actually affect the quality. So they actually advise you to transfer to a bit higher temperature normal fridge for 5 days only you use. That's why a lot of logistics, you have to do the timing. Then you have to make sure once the batch is defrost, you have to use it within also, I think it's 2 days or 5 days. So a batch of the things is about 900 something shots. Not more than 2,000 shots, it's 900 something. So you have to ensure you use up, otherwise you will waste that. So logistically, this is different kind of animal. I mean, the mRNA vaccine compared to the inactivated vaccine, and then those virus vector vaccine.
Thank you, Dr. Lim. So I have one question from our committee member. He asked, may I know why the vaccine is injected into muscle instead of the bloodstream?
Well, you want the actually we want the immune cells to just go and pick it up and contain in a local area. If it goes to the bloodstream, you don't know where it will go to. Although you know if the nurse or the caretaker didn't inject it properly, also will cause some damage, and it will also eventually escape to the capillary and bloodstream. But try they would the best is try the best as possible to inject just in the local area so that it's already good enough because the local innate cells can already pick up the vaccine substance, no matter what it is, and digest and do their job. If you leave it to the bloodstream, that means it go to like brain and other area you don't want to, then it could cause other difficulties and side effects. Yeah.
Thank you, Dr. Lim. So from our participants' question, the question is, does the COVID-19 vaccines protect against variants?
Yeah, that depends on which variant you're talking about. The VOC is the tough ones. Currently, it's only 5 listed on CDC. Actually, 3 are global. The UK strain actually already got around more than 100 countries. South African and Brazil's variant more limited, and the other 2 listed by CDC actually happening in just in US. So all this have shown some effect on to reduce the efficacy of the vaccine. Other than that, the BOI, all this so far okay, and even though reduce the efficacy of the vaccine, but the cellular immunity, if you look at other scientific literature, is still intact. It's still good enough to prevent you from sickness. Just that if you look at the antibody performance, it's just not very convincing. Just reduce efficacy, but the cellular immunity is still working tip top right now.
So the next question is, since India appear new mutated COVID-19, is the vaccine still effective?
India's situation is worrying because infection there is uncontrollable. We worry for more emergence of more challenging or more dangerous variant. Currently, they are studying about the VOI. Probably there are more VOI right now in Indonesia. VOI, they are still not. They don't have concrete evidence that this shows that this variant actually causing more troubles that the current vaccinated people cannot contain. All this you need more studies. Yeah. So now there's no evidence. Doesn't mean that they probably in the later stage, if they found any more threatening one, then they would upgrade it to VOC. How to determine? I think one very good indicator is that the one variant actually dominate the whole certain demographic region. If that is true, that means this shows that this variant has certain advantage over the other kind of current existing variant. It should be a cause of a concern and already. So currently, we are really worrying about the situation there.
As for the next question, after accidentally contacting with the COVID-19 patient, should we direct to do the swab test, or we need to self-quarantine first before doing swab test? Because the virus got the incubation period after getting in our body.
Correct. Good question. Although I'm not a doctor, it's just from what I understand about the pathogenicity of the virus, yeah, you shouldn't go straight away because a lot of people don't understand. The virus need to incubate. It means they got into your cell. They need to replicate to a certain numbers in order for the the healthcare person when they swab you to detect it. So if you go too early, of course it's negative because there are hardly many copies out there. But that doesn't mean that you're not infected, because later days when they grow to a certain size, then that was the time you start to show symptoms and can easily infect others. So don't go any time before 5 days. Yeah, before the exposure. After 5 days of exposure, for the first 5 days, just not good. Just be patient. I just have to do some kind of timeline research and understand your risk. Close contact to close contact to close contact. Then you just wait for the close contact, and then you calculate from how many days of exposure after you see this person. So you have to ask the close contact when did he meet the other person. So all this you have to do some calculation and see whether you are at risk or not. Yeah.
Thank you, Dr. Lim. Another one interesting question from our audience. Doctor, since Israel is not a vaccine producer country like us, so why is it that Israel can get many of its people vaccinated?
Very good question. Simple answer is Israel is a rich country. They got money. They actually pay the price for most higher premium than many others. I think this vaccine market is no other than drug market. Whoever pay the highest probably will get the supply lah. Well, it makes a lot of sense. And another thing is that the Israel health authority approached Pfizer for some kind of data collaboration. That's why they can give you the study just now I show you. Plenty of millions of people already got vaccinated, so they have the data. So it's like a feedback to Pfizer also. So they provide money and data. So these two give them the advantage. You can also ask why Singapore faster lah. I will also tell you probably it's the money lah. It's the money. Then you ask why Malaysia not paying more. This is the thing lah. When government procure at a higher price, you say, oh, something wrong, maybe corruption or something. Why government is not making the best deal for the people? Then now they want to ensure the procurement is reasonable. Then say you could accuse them for being slow or things like that. But I think government should always negotiate at a reasonable pricing. It's not. I actually against those say should go for higher premium and get it faster. Actually, you get it faster at expense of other people. Also, you see those developing countries, if they don't have money, they don't get any vaccination. Is it fair? Is it the fair way we should live in? That's why I would beg to be differ. I guess right now the progress is okay, but at the beginning the supply is just coming short, and it's not totally government's fault for not vaccinate people fast enough, because they just don't have their supply. They start to get more. For example, the AstraZeneca. From the news that I follow previously, is that the first batch actually is expected to arrive in June. Now, in May, we already got it first. I think it's something to do with the blood clot public scare worldwide, and there are many countries actually suspended the program. So they suddenly have more supply and they can give away under the COVAX facility. So we got it actually earlier than expected. So it's not a bad thing that I would say is, yeah, if you got the choice of having the AstraZeneca and can come, you can use the first come first serve basis to get it faster. Why not? I think it's fair because currently the second phase is for the elderly population, and they have the most reserve about the risk of side effect. We cannot wait forever for them. So whoever you think the risk taker, you want to get faster, just do it. I think it's not really that risky, just that hopefully you are now aware that you should expect certain kind of side effect. Usually the younger population would have more vigorous response towards intruders. I mean the foreign pathogen or substance. So that means you feel the side effect actually stronger than the older people. But it's not a bad thing because this shows that actually we should have a better response developed later, because older people probably less sensitive to things, and that's why because of information, and probably younger people will receive more information and better informed than the elderly. So this reservation about the vaccine actually prompted mostly and MOH to have this opt-in strategy. I think it's a fantastic move.
Thank you, Dr. Lim, for the sharing. So the next question is, does post-COVID-19 patient need to vaccine? Because some said they have immunity towards the virus.
If I'm not mistaken, it's a good question. I think that the MOH has not come out with advisory yet. Whether you definitely should refrain from taking or not. I guess you would probably need another dose to boost your response. If you look at the data I showed you before, generally the 2-dose vaccination will have a much higher antibody titer compared to those recovered patients. That's a fact. But that doesn't show, like I said, doesn't show the quality of it, but the quantity wise, it shows that vaccination actually can give you strong protection. So probably I would say that you probably need a booster dose. After that, it's no harm because it's just taking it as like an update to your immune system. So yeah, just wait for the MOH advisory.
Thank you, Dr. Lim. I have one more question here. Is there any other methods to prevent new variants from emerging other than reducing the overall spread of virus?
I wonder if you mean preventing the emergence of variants, or you're preventing this variant coming to our country. These are two different concepts. To prevent the emergence of variant, that means we live in this world should be all together to resolve this pandemic as soon as possible. So that we also should ensure that vaccines equity is there for everyone to access as soon as possible. So it's not good that like a whole Israel, a whole America got fully or mostly vaccinated, but a lot of different countries still got their pandemic worsening, ravaging. It's not good because the more you let the virus incubating in the local community, the more chances you will get the emergence of new variants. So this the lesson that many rich and developed countries should take, and we in Malaysia also should also support any effort to ensure the vaccine equity. Currently, there's no treatment to deal with COVID-19. Yeah, So that's why we have to rely on our public health measure to limit the spread of the virus. Other than vaccination, there's no other effective measures other than the public health measures that we can see right now, the SOP, the MCO thing. Yeah, so we can only play with all this right now.
Okay, thank you, Doctor. One more question is, as Ministry Youth and Sport released yesterday that we can now sport at neighborhood, as from Dr. Adiba Kamaruzaman, who is a professor from infectious diseases and member of the WHO Science Council, the risk of getting COVID-19 in outdoors is about 18 times than indoors. So, Dr. Lim, what do you think that in MCO 3.0, we will be good jogging or just yoga in house?
Thank you, Wei Feng. Yeah. I need to study her statement because I'm quite confused and probably have to understand the whole context of her saying that. So currently, it just does not make sense to me about that statement. I don't understand why. I think jogging should personally, if you just do a individual sport, non-contact sport, not a problem. Like I told you, to get infected, you have to go through some kind of a human interaction, close contact. For example, if you you have some contact with people in a short distance without wearing masks, all this, that will increase your chances. If you just alone go out jogging, no chances. Yeah, of course, if you see somebody sneezing or coughing, stay away. I don't think you will jog that close to the person. Yeah, so yeah, as long as you can keep the physical distance, I don't see any problem of not wearing masks also, because there's no chances for you to get infected.
Thank you, Dr. Lim. We have one last question from our audience. How to differentiate between RNA and viral vector vaccines?
Yeah, viral vector vaccine, they will need to use live virus to carry the mRNA. And mRNA vaccine is just mRNA they put into some kind of lipid structure. It's not a living organization. It's not a pathogen, you know. So it's not a kind of thing that can infect you. It's just a molecular thing for mRNA vaccine. So that makes a difference. One is a viral vector, virus. It's the vaccine substance. Another is just a molecule.
Okay, thank you, Doctor. So I think we can move to the photograph session. Thank you, Dr. Lim, for the wonderful sharing. I think it's all for the Q&A session. Let us take a group picture with Dr. Lim. Now I would like to pass to multimedia.
All right. Thank you, Ian. So now everyone, please turn on your camera and smile for a few seconds. Please turn on your camera and smile for a few seconds.
Happy to see all of you.
Okay, I will take photo right now, yeah. Please hold your smile. In 3, 2, 1. Again. In 3, 2, 1. All right. Thank you. Now I would like to pass back to MC. Thank you.
Thank you, Dr. Lim Jihan, for the wonderful sharing. I hope you guys get a lot of information today. Now we will proceed for the following session. For your information, you will have a group project based on the talk just now. Let me invite Edison from Unit Activity to explain it in more detail. You can ask any question that you need to clarify during this session in the chat box or unmute yourself to communicate.